Illustration 3. Shivam Limited is considering two mutually exclusive projects A and B. Project A costs 36,000 and project B costs 30,000. You have been given below the net present value probability distribution for each project. So these are the NPV estimates and their respective probabilities. So as I told you previously, total probability will be 1 always. So NPV estimates for project B and their respective probability. First one, compute the expected net present values of project A and project B. So we have to multiply this net NPV estimates with the probabilities. So then we will get the expected net present values. Second one, compute the risk attached to each project, that is standard deviation of each probability distribution. So first of all we have to calculate the variance, and then it is very easy to calculate the standard deviation. Root of variance is the standard deviation. Third one, compute the profitability index. So profitability index, PV of inflows by PV of outflows. So this one is the special when compared to the illustration 2. Which project do you recommend? State with reasons. Okay. So first of all, computation of expected net present values of project A and project B. So I am taking the values of the above table, NPV estimates and probability. So expected values we have to calculate. So 15,000 into 0.2 is 3,000. So 12,000 into 0.3, 3,600. And 6,000 into 0.3, 1,800. 3,000 into 0.2, 600. So total expected values comes around 9,000. So expected values of project B. So 15,000 into 0.1, 1,500. So 12,000 into 0.4, 4,800. 6,000 into 0.4, 2,400. 3,000 into 0.1, 300. Total will be 9,000. So with this, expected net present values of project A and project B is over. So second one, computation of risk attached to each project, that is computation of standard deviation of project A. So we have to prepare a table to calculate the variance. So this is the formula of a variance, sigma square of possible events. So net cash flows are NPV estimates. Net cash flows are NPV estimates minus total expected cash flows. Total expected cash flows of project A is 9,000. So these are the total expected cash flows for each and every possibility of event. So we have to do power 2 squaring. We have to square. So again we have to multiply with the probability. Okay. NPV estimates into, sorry, NPV estimates minus expected values, that is 6,000, 6,000 and 3,000 and minus 3,000 minus 6,000. So we have to do 6,000 into 6,000, 36, 3 crores 60 lakhs. Actually, if we calculate by using this formula directly, it won't be a difficult. For easy understanding, I prepared a table so that it will be easy to understand. So 15,000, 90 lakhs. So here minus into minus becomes plus. We have to multiply with the probability again. So the values will be 72 lakhs, 27 lakhs, 27 lakhs again, and 72 lakhs again. Total variance is 1 crore 98 lakhs. So now it is very easy to calculate the standard deviation of project A. Project A, that is root of 1 lakh 98,000. So it comes around 4,450. Same procedure, we have to calculate the variance and standard deviation for the project B as well. So I already calculated. So NPV estimates of project B and 9,000 expected values. So only probability differs here. That's why values get changed. See, only probability is the difference in both cases. So variance will be 1 crore 44 lakhs. So the standard deviation of project B is root of 1 crore 44 lakhs. It comes around 3,795. So if you take the standard deviation as a decision criteria, the lowest standard deviation is having by the project B. Now, third point, calculation of profitability index. Computation of profitability index or calculation of profitability index. PV of inflows by PV of outflows. I just mentioned the formula as well. So for project A, how to calculate this profitability index. So PV of inflows by PV of outflows. We know the PV of outflows, that is 36,000 for project A and 30,000 for project B. So what are the present value of cash inflows? Here we have to consider the risk factor, so that after considering the profitability, whatever we get the expected values, we have to add this to the project cost. That will be the PV of inflows. So expected cash flows expected NPV plus project cost by project cost. So even if you calculate by reversing all these formula, you will get the same values. So expected NPV, project A 9,000, 9,000 plus what is the project cost for project A? 36,000. 36,000 by 36,000. So profitability index is 1.25. So same procedure for the project B. Expected NPV by project cost divided by project cost. So PV of inflow, project cost is nothing but PV of outflows. So 9,000 is same, but in this outflow is 30,000. Here also 30,000. So profitability index is 0.30. So now the recommendation for this proposal is in the selection of one of the two projects A and B. Project A is so project B is preferable. First one, the possible profit which may occur subject to less variation or dispersion. Much higher risk is lying with the project A. So project B, as I told you, as per the standard deviation, it is lower than the project A. That is why project B is preferable than project A, because project A is more risk, is having more risk. So next, illustration 4. Project X and Y, expected NPV, standard deviation. Which project will you recommend based on the above data? So, in the above data, standard deviation is lower for project X than the project Y. So, as per the standard deviation, project X is recommended. Explain whether your opinion will change if you see coefficient of variation as a measure of risk. So coefficient variation formula is standard deviation divided by the expected NPV. So let us calculate solution. One, as per the standard deviation, project A is recommended. As it has lower standard deviation. So in the second one, explain whether your opinion will change if you use a coefficient variation. Coefficient of variation. Coefficient of variation formula is standard deviation by expected NPV. That is project A. Oh, project A is equal to 90,000 divided by 1,22,000. Project B is equal to 1,20,000 divided by 2,25,000. So values will be 0.738, 0.533. So on the basis of coefficient variation, project X appear to be more risky and project Y should be accepted. So this is the case where standard deviation is preferring project A and coefficient of variation is preferring project B, project Y or project B. Okay, XY. I'll change the XY. So coefficient variation is choosing project Y. So in some situation it may arise like that. So in such case, which measure is more appropriate in this situation and why? So if situation arises like this, we have to go with the coefficient variation, because coefficient variation is the best measure to evaluate risk proposal having different expected NPV and standard deviations. Okay, so the same thing I'm providing the reason. So coefficient variation is the best measure to evaluate the risk of proposals having different expected NPV and standard deviation. Okay.